So here I've imported some fish data from Kaggle in which we can build our regression model on and later evaluate it. So I downloaded the data and stored it under the folder project data. You can then view the first few rows by naming the data frame and then doing .head. And we see here that we have the species of the fish, the weight, and then also length 1, length 2, length 3, which doesn't seem quite clear as to what they mean, and then the height and then the width. And so from the Kaggle website, I figured that length 1 referred to the vertical length of the fish, length 2 the diagonal length, and length 3 the cross length. I've just renamed those columns here. So the next thing I did is I one-hot encoded the species. If you guys aren't sure what one-hot encoding is, I would recommend looking at the data pre-processing steps of project 2 of this series. So here I've one-hot encoded the species. You can then look at the shape of our data frame. So here we have 159 rows and 13 columns. And the job of our regression model is to predict the weight of the fish given all other features. So here we define the input data for our model as every feature apart from the weight. And our target variable we define as the weight. Then we can then split the data into a training and a test set. And here we're using a test size of 15% and therefore a training size of 85%. We run this here. So here I've imported linear regression from the scikit-learn library and I fit the model to our training data. Run this here. We've now fit our linear regression model to our training data. So now that we've built our model, we can now go on to evaluate and try to make improvements. The first thing to do is to get a set of predictions. And here I've stored it under the variable y_pred. And here we use our model. Then we use the predict method. And here we're using our test data since we want to see how our model performs on data that it hasn't been built on. So here we get a set of predictions. We can then view these predictions. You can see here. So let's now go through the different evaluation metrics explained in the previous episode. So here I've imported mean squared error from the scikit-learn library. And this takes two values. First, the y_test, which is our actual y values in our test set, and y_pred, which is our set of predictions which we've defined here. We run this here, we get our mean squared error. To get our root mean squared error, we simply set the squared parameter equal to false. Here gives our root mean squared error. We can also get the R2 score, and here we've imported the R2 score again from the scikit-learn library. And we can also look at the adjusted R2 score, and here I've simply just defined the variables that are used in the adjusted R2 score formula, and then I've applied the formula here. And if we run this here, we get our adjusted R² score. So from the get-go, we see that our R² score is very good with a score close to 1, and the same for our adjusted R² score. Let's try adding some polynomial features up to the 3rd degree. So for this, I've imported polynomial features from scikit-learn, and I've set the parameter degree equals to 3. I've then transformed our data and stored it under the variable x_degree3. So if we run this here, we can then look at the shape of our new transformed data. So previously we had 13 features, and now we have 455, and these extra features are due to interaction terms and also terms up to degree 3. And these extra features could be, for example, plus the vertical length cubed, or plus the diagonal length times the cross length squared. There are so many different combinations that we could have which add to these extra features here. So as before, we then split our data and then fit the model to our training data and then get a series of predictions. But this time we're using our degree 3 model on our test data. We'll run this here. And now we can look at the new R2 score of our model with more features. And we see here that it's actually a very poor R2 score, performing even worse than a base model that just predicts the mean weight for each observation. This very poor R2 score on our test data would suggest that we need to make some changes to our model. So since we've added more features to our model and our R2 score has decreased, I suspect this is due to overfitting. We can check this by looking at the R2 score on our training data. If we see that the R2 score is very high on our training data, this would mean that the model is overfitting our data. We run this here, we do see a very high R2 score on our training data. So let's now try to improve our model. So instead of including terms all the way up to degree 3, let's just look at interaction terms. So for example, we could have the diagonal length times the cross length, or the height times the width, or the species bream times the height, and so on and so forth for different interaction terms. So the same concept applies. We transform our input data x, and let's now check the shape of our data to see how many features we have. So here we now have 79 features, and then we apply the same method as before. We split our data, we then fit a model, and then produce a set of predictions. Run this here, and let's now look at the new R2 score. So here we see that our R2 score is roughly 0.964, which is higher than our original model's R2 score. We can also look at our model's performance on the training data, but this isn't really needed since we already have a high R2 score on our test data, so we wouldn't have to check for overfitting. We can also take a look at the adjusted R2 score, but here we get an adjusted R2 score bigger than 1. Since our number of test examples n, which is equal to 24, is less than the number of features in our model k, which is equal to 79, we end up with an adjusted R2 score bigger than 1, so this may not be useful in evaluating this particular model. For models where there are more test examples or less features, the adjusted R2 score can be quite useful, since it can give an indication of overfitting models. Thank you for watching, and I hope you learned something new.